Good afternoon. So I am Ravinder Singh, Assistant Professor in the Department of Mechanical Engineering, Birla Institute of Technology and Science, Pilani. Today I am going to explain the practical on the variable compression engine. So variable compression engine is what? So when you are going to vary the compression ratio of the engine. So what do you mean by compression ratio? Basically it is the volume of the bottom dead center to the volume at the top dead center, that is called as the compression ratio. What is a compression ratio? So volume at the bottom dead center to the volume at the top dead center is called as the compression ratio. So as you know that the efficiency of the engine is directly or you are having some correlation with the compression ratio. So the efficiency of the engine will be having some correlation with the compression ratio. It means if you are going to vary the compression ratio, so it means we could change the efficiency of the engine. So variable compression ratio engines, so it has been existed for a long, but due to some limitations in earlier times, so the variable compression engines are not possible. But these exist only in the laboratories. But since last 10 years or 15 years, so the commercial production of the variable compression engine is taken place because of the advancement in the new technologies and advancement in the manufacturing technologies. So the variable compression engines now these days actually so produced by the companies, and actually they are started commercially available in the some of the cars. But still it will take a time so that the full of the variable compression will be going to replace the market of the fixed compression ratio. So what is the aim of the experiment? The aim of the experiment is to determine the performance characteristics of a variable compression ratio petrol engine at a rated speed and a variable. So our aim is to determine the performance characteristics at a rated speed and then at a variable. So what we will do? So since it is a variable compression engine, so we will try to vary the compression ratio and we will try to vary the load. So what is there in this? So first of all, so this variable compression ratio. So here this type of the arrangement is there in the experimental setup. So the variable compression is varying with respect to the changing the clearance volume that is available at the top of the arrangement, top of the piston cylinder arrangement. So we are having this piston cylinder arrangement in which the main piston is there, and at the top of that so we are having the auxiliary piston. So we will vary the, so as you told that the volume of the bottom dead center to the volume of the top dead center is the compression ratio. So if we are going to change the space at the top dead center, so we will change the space at the top dead center, either you should change the clearance volume or you will change the clearance volume at this volume. So either change the clearance volume or you change the clearance volume at this volume. This is how you are going to vary the space. So this piston at the top, auxiliary piston, it will be adjusted. So with the help of the arrangement, secure arrangement present at the top, so you could move the auxiliary piston, move up and down. When this is moving up and down, so this causes the space between the clearance space. So this clearance space is what? The space between the top dead center and between the auxiliary piston. So where the up to the cylinder head at the top of that. So that is what the clearance space. So that clearance space is varying with respect to this auxiliary piston. So the main piston is doing its own work. So it is connected to a crankshaft that is connected to a further motor generator, so that it will be able to load the performance of the engine. So the variable compression is there. So let's say we fix this thing and we fix the clearance volume. So what is the R1 now? It will be volume at the bottom dead center 1 and then the volume at the top dead center. So it is the first compression ratio. We move this wheel. Now it will be moved a little bit downward. So when it will be moved a little bit downward, causing the space clearance volume to reduce. So when the clearance volume is reduced, so that is going to cause the change in the TDC, because the clearance volume is reduced. That is going to cause the what effect? The compression ratio. So we will able to get the another compression ratio. So we will able to get the sum of the fixed compression ratios for a combined engine. So you could vary this thing. This is simply the one method. So that we were having a main piston at the top of that auxiliary piston, but actually the clearance space and the swept volume that could also be varies with respect to the movement of this main piston. You will have another cylinder in which the another auxiliary piston will be. So you have a main arrangement, you have the another auxiliary arrangement, and then you are having the crankshaft below. So we could make the arrangement in the crankshaft such that this swept volume will be going to vary. So but discussing the many other parts related to this will be beyond the scope of the experiment. So that will be covered in the theory classes separately. But here we will fix only we will only do the experiment part. So I hope the variable compression ratio is clear to you now. Now let's move to the why. What is the major benefit of the variable compression ratio? The major benefit of the compression ratio is it is affecting the efficiency. So at higher load, it requires a compression ratio for a more efficiency. So what is the case? For any petrol engine, so when you are having a higher load, so if you are having a lower compression ratio, so then the efficiency will be higher, and vice versa, if you are having the lower loads, so then you are having the higher compression ratio required for the higher efficiency. So to have a higher efficiency, you have to build the compression ratio. So this is what the main thing in the petrol engine. So this thing is possible with respect to the variable compression testing. So I hope the concept of the variable compression testing is now clear to you. Now let's move to the equipments part. So what are the equipments that will be used in this experiment? So first thing is that so these are the equipments. So first thing is the single cylinder 4-stroke air and water cooled. So single cylinder 4-stroke air and water cooled engine is there. So single cylinder is there. So we could have a multiple cylinder also, but for this experiment we are only having a single cylinder, and this is a 4-stroke engine, 4-stroke petrol engine. So in which the auxiliary piston, that is the piston situated at the top, is cooled with the water. The piston situated below, that is the main piston. So that arrangement below that is cooled by the air. So in the engine itself, auxiliary portion is cooled by the water. Below that, so what you are having the main piston, that is cooled by the air. So that is what there for this single cylinder arrangement. Now what is the specification of this single cylinder? It is having a 2 horsepower at a 2800 rpm. So this engine is capable of moving from some fixed rpm like 2500, then it may go up to the 4000 rpm, or even so you may even operate at a 2200 like this. So from that 2200 up to the 4000, or something it will be up to. So these are some approximate values at which this engine will be going to operate. So what are the rated speeds? So rated speeds like the 2800, and then at that rated speed, what is the load? It is the 2.5 horsepower is the power of the engine. So that will be available for this. Now the another specification is that what is the variable compression ratio? 2.5:1 to 8:1. So the variable compression ratio for engine is 2.5:1 to the 8:1. So you have having a R is the compression ratio that could vary from 2.5 to 8:1. Then you are having a DC generator. So this engine is coupled with the DC generator. Why generator? So in this experiment, first we will run the engine on a engine mode, and then we will redo the experiment, and then we will run the engine on a motor mode after cutting off the petrol. So this engine is coupled with the DC generator. This is the third equipment in this test rig. What is the fourth part? We will have a resistive load bank to apply the load. So we will have the electrical. So that is based on some resistances. So you could vary the load from 0 to the 2000 watt. So you could have a no load condition. All of resistive loads at a 0 position. You could have one switch on. So 500, another 1000. Like this with 1500, 2000. Like this with various many combinations are there. For 500 you may also have a 25. This 250 like this. So the resistances are there. So this resistance is basically going to apply a load, so you could vary a voltage at a current, and that will be passed to the resistance load, so that will be applicable to the engine. So the load will be applied to the engine to vary the various loads of the engine. Then you will have an exhaust gas calorimeter. So exhaust gas calorimeter is what? So it is a device basically so used to remove the heat from the exhaust gas. So it is a device used to remove the heat. So should not be confused with the bomb calorimeter. Bomb calorimeter is used to determine the calorific value. So exhaust gas calorimeter is a device basically used to remove the heat from the engine, and then it will be passed to the atmosphere. Then you are having a digital air fuel consumption and a temperature meter, so that are also there in this testing, but unfortunately so only temperature meter and the air meters are working in this. Okay, so now what we are having, so after the equipment, so this is what the main testing, so the circuit diagram of the main testing. So in the circuit diagram we have what we are having on the screen, so left hand side, so when you will enter in the lab, so this testing is there. So in that, on the testing extreme left hand side, what we are having the resistance load. So this resistance load is on the left side of the testing. So then we are having a panel to do all of these or to note down the various readings. So in the panel, so what we are having the temperature indicator, fuel consumption. As I told you, unfortunately the fuel consumption is not working, this panel is not working, we measure the fuel consumption manually. So temperature for all of these 6 thermocouples that are applied on the engine can be noted. So you could switch on, you could move this knob and the temperature reading will be there on this panel. So then on the panel what we are having, so you could note down the speed, so a sensor is there to note down the speed, so we are getting a digital reading on this panel. So 2800, 3000, 3200 all of the readings are there on this. So then we are having a start button on the panel to start the testing, but that is also not working. So we will going to start the testing manually. So manually we will start. So the start button is also not working. Then there are the 2 knobs to increase the speed and decrease the speed of the engine. So we are having a knob. So we are having a knob related to the motor and knob related to the generator. So first of all we will run the engine so on a generator mode, and then again we will run the engine on a motor mode. So the 2 things are there. So generator mode means that the supply of the fuel to the engine, it will be there, and then loads and all the things are there. We will apply the load and we note down all of the currents and various other readings. So that will be the generator mode, and then the other thing will be the reverse mode. So you will have going to have the motoring thing. So we will cut the fuel. So we will cut the fuel. So we will see the connection. We will move into the motor side. We will cut the fuel, and then all of the connections, spark plug is removed so that there will be no combustion phenomena in the engine. Then with the help of the motor, so we will slowly apply the current so that the engine will be going to start at the same RPM. So engine will be going to start at the same RPM. So hence the engine will be going to run it on a motor mode and the generator mode. So the same speed will be there for a motor mode, same speed will be there for a generator mode. If your engine testing is running at 2800 RPM, 3000, so then after cutting off the petrol spark plug, so your testing, so in the reverse mode, it should also run at the 2800 and it should also run at the 3000 RPM. Now what we are having, so in the testing, so you will be able to get the measurement related to the voltage, and you will also get the measurement related to the current. So you could move this knob, so when you are running it on the reverse mode, so that you could move this node, so that you will be able to vary the voltage and the current. So when you are running the engine in a reverse mode, what should be the case when you are running the engine on a reverse mode? So you have to check that so there should be no resistance load, spark plug should be cut off, and then this knob should be checked, motor and generator, that should be on the motoring mode, and then you will see that you are going to apply the fixed amount of the, so there should not be load, so you will check that, so the load applied to the engine, that should also be there. So here on this thing, so load applied to the engine will be there. So we will get the voltage, current and the RPM. So this is the only information you need when you are going to run the engine on the course. Then we will have the engine. So we will have on the extreme right side of the panel, engine is there. Which the variable compression engine is run. So you would measure with the help of this wheel that is situated at the top. You would move this wheel, fixed RPM first, and you move up and down. So then the compression ratio is adjusted. So first X1 any compression ratio, you move this wheel down, R2 another compression ratio, this B another compression ratio. When you are having a fixed RPM, so fixed compression ratio, you run the experiment and you will try to note down the reading. So we are having this engine, at the bottom of that motor generator is there, so that will be attached, and on the other side same brakes you are having a exhaust gas calculator. The exhaust gas from the engine, it will be passed to the exhaust gas calculator, and then it is exhaust gas calculator, basically it is a shell and tube heat exchanger. From one end the supply of the water it will be there, and then from the other end the same supply after passing through the engine it will be coming out. So it's shell and tube heat exchanger, it will be basically responsible for removing the heat from the. So this is our body testing. At the other side you are having the airbox. So that airbox is again connected to the panel. So we will get the information of the direct meter cube per hour on the panel itself. On the panel itself, so we will have some kind of the indicator for air consumption, in which you will get the reading meter cube per hour, meter cube per second. So meter cube per hour that will be there in the panel itself. So air consumption will also be there on the panel. All of the temperatures T1, T2, T3, T4, T5 and T6. T6 is the ambient temperature. So whereas T3 is the water inlet temperature to the exhaust gas calorimeter, T4 is the water outlet temperature from the exhaust gas calorimeter. T1 is the water inlet to the exhaust gas calorimeter after passing from the engine. Then you are having a temperature that coming from the engine T5 that will be there. That is also the another temperature. So this is our body testing that will be there. Now we'll see what are the various measurements to be taken, and then we'll see that measurements, and later on what we will move to the lab to see the actual numbers. Yes. Now we'll see what are the readings to be noted down. So we are going to make the two tables. So first and second. So this will be the reading measurements that will be taken from the test. So first of all, we will see that what is the compression ratio. So as I discussed, so at the knob, after adjusting the knob, so we will have value of the fixed compression ratio. That's 3.5 is the first compression ratio. Now if you fix the fixed compression ratio, now we'll start the engine. We'll see the various electrical connections. There should not be loose connections, should not be there. And first of all, we'll run it on the engine mode, so that the fuel will be there. So we'll check the fuel in the fuel tank. There should be the fuel in the fuel tank. So that should be checked. Now after checking that, so we'll start the testing manually. So once we start the testing manually, so engine is started, we'll slowly increase the load. So slowly increase the load, and then slowly increase the speed. So first of all, we'll see that it should be at a no load condition. So we'll slowly increase the speed till the RPM of the engine it will be 2800. So the first reading will be 2800. So first reading 2800. Now there is a fixed RPM 2800. We need to conduct the experiment at a 2800 RPM. So once the 2800 RPM is fixed, now what you will do? So you could note down the V and I corresponding to the zero load condition. So you will see that we have seen that no load condition is there. Corresponding to low load, you see the measurement of the air, how much air is then the time. So see how much the fuel is consumed in a balloon. basically 40 cc is the volume of the color. Correspondingly, we will take a stopwatch and then with the help of the stopwatch 40 cc is consumed. That time is noted, that will be noted down. Let's say this is 10 second. Air consumption rate, let's say it will be 8 meter cube. So the load V and I current from the panel, that will also be noted. Any of the reading X and Y, this should be there. So this is the first reading. So correspondingly, you will see first reading T1, what is the temperature T1, then what is the temperature T2, T3, T4, T5, T6, that will be there. Then you will see how much is the supply of the water to the engine. So that will be basically in the liter per minute. So maybe in the manual it is cc per second, liter per minute. So to the two rotameter, that should be also noted, and the water supply to the calorimeter. Now this is what the first set of the. Now what we will do with the help of the resistive load and knob, so we will increase the load. So the second reading it will be 500. So 500 watt load will be applied. This is the second reading. So then correspondingly the fuel consumed, let's say 12 second. Then air consumed 8.5 RPM. C, the RPM should be fixed. Unless or until RPM is not 2800, you are not allowed to take the second reading. Then see the current again Y2, then see the voltage L2, that should be noted. Similarly, second reading T1, T2, T3, T4, T5, T6, and then how much water consumed through the first rotameter to the engine, then to the calorimeter. Now third reading, apply the load to 1000. So fuel consumed 40. It will be let's say 10. Then it will be Y3 X2. So similarly, third reading is temperature. Some of the temperature should be noted. So how much water is there consumed in this engine, then how much water is supplied to the calorimeter. So that should also be noted. So similarly, you increase the load up to the 1500. You will see any of the reading for a fuel consumption, air consumption, then C, Y, Y4, then X4, and similarly you will note down all of the temperature reading corresponding to that. And then again water supply, that should be noted, and water supply to the calorimeter, that should be noted. Now this is the case for a engine. So this is what the case for a engine. So once we are dealt with the all of the case for a engine, now what we will do, we will switch off the engine, we will see that the fuel supply is cut off, we will see spark plug is cut off, we will see thoroughly there should be no resistive load, and we will see that engine is purely in a cut mode. So now we will apply the engine in a reverse mode, and we will see the motoring effect on the engine. So when we will do the motoring test, so in that case we will simply apply the voltage and the current that will be consumed by the motor to run the engine corresponding to what, at the same speed. So we will slowly apply through the knob voltage and the current till the speed is now 2800. Why 2800? Because we have done the experiments at the 2800. So till the speed is 2800. So V and I, that should be noted. So this is the motoring test done. So this experiment is complete. So similarly, so this should be first reading. Similarly, we will do for a second set of the reading at another compression ratio X2, and then third compression ratio, fourth compression ratio, and all of these things that should be repeated. So once you noted down all of the readings, it is now to do the calculations. So once you completed all set of the 4 readings, now it is time to, you can say, do the calculation. So let's do the calculations. So we will come to the calculations. So we will see, so brake power, so voltage into the current divided by 1000, generator efficiency, so brake power is calculated, then correspondingly frictional power is calculated, VI is efficiency of the motor, it is given to you 0.8, so that should be frictional power calculated, then mechanical efficiency 40 cc and into the, so various things related to how much time it will be there. So related to that, this is how the fuel consumption is calculated. From the fuel consumption, so mass of the fuel, so you will get the divided with the brake power, so brake specific fuel consumption, and if you will divide it with indicated power, indicated specific fuel consumption, that will be calculated. Then you will calculate the amount of the air. Now this amount of the air is no need to calculate because it is coming directly on the panel. So these calculations are done already by the instrument supplier who supplied the testing. So as there will be not there, so the density of the water, density of the air, so these all things are already calculated, and we are already having the fixed set of the amount of the air flow that will be coming directly on the panel. So you will have a swap volume pi by 4 d square ln by 260 that you need to calculate. Then you could calculate the volumetric efficiency based on the air that will be consumed based on the swept volume, what will be the volumetric efficiency of the engine. So finally you could calculate the brake thermal efficiency, you will calculate the indicated thermal efficiency, and you could make the heat balancing. So what is a heat balancing? Basically how much heat is entered into the system, into the, so that is the heat balancing. So amount of the fuel consumed into the calorific value of the petrol, because petrol engine tested, so that will be the amount of the heat entered into the system. So brake equivalent of that heat input, so brake power into the 3600, that is the, sorry, heat equivalent of the brake power. Heat equivalent of the brake power is to be calculated from the brake power. Then what will be the frictional power? So the heat equivalent of the frictional power, F3 into 3600, that will be calculated, and then heat carried by the exhaust gases and carried by the cooling water. Mass of the cooling water that is required for a engine, CPW 4.18 into the delta T, amount of the water, that the temperature of the water entered in the engine then exit. So that we will get information from the panel, and we have noted down in the table, and that is first. Then second, the amount of the gases into the CPG, maybe 1.12, and then into the delta T, that is also measured. So then we will calculate the amount of the heat carried by the gases, and finally how much is the heat accounted for the unaccounted losses. So we will subtract from the total, so all of the losses, so brake power, frictional power, and then the heat carried by the cooling water to the engine and to the exhaust gas calorimeter. So all of the heat should be calculated, and this will be H4. It will be the heat carried by the, so the heat, that is the heat carried by the unaccounted losses. So with this, so set of the readings is complete, and then you have done the calculations. Now you could draw the various plots related to the brake power, or you could draw the brake power versus the efficiency, or you could plot the n number of the graphs based on the readings. So you could plot the various readings on the graphs, and your experiment is complete. Now we will see how the engine is running, and we will see the actually what are the various parts of the. Okay, so let's run the experiment. So what we are having, so first thing is, this is what the, so single cylinder 4-stroke petrol engine. So this is what the single cylinder 4-stroke petrol engine. So at the bottom of that, so what we are having is the main piston. So this is a main piston, so that is connected, so main piston is there here, and then at the top of that, so what we are having the auxiliary piston. At the top of what? So this is what the auxiliary piston. So how we are basically setting the compression ratio, as it is a variable compression ratio. So we'll just move this thing, move this wheel, and the compression ratio is set. So on the extreme side, so you are having the meter for the variable compression ratio. So you see this calibrated reading, so it varies from 2.5 is to 8. So there is a reading from 2.5, then you are having a 3.5, 4.67, so then 6 and 8. So these are the fixed set of the readings for the variable compression. But in between that, we don't know what type of the variable compression ratio it is. In between means what? That the ratio between 3.5 and 4.67. So if we are going to set between that, we don't know whether it is 4 or whether it is 4.2. So we are only going to run this for a fixed set of the reading. So we fix it. Now this is fixed. If you want to change, you could change it like this. Now this is fixed for one set of the reading compression ratio R. So that is the fixed now. Now in this engine, so to measure a speed, so here so speed indicator is there, sensor is there, so that will give you the speed. So here on this crankshaft, so the speed indicator through this electrical connection, so it will be connected to a panel. So on this panel the speed will be noted. So through the panel the speed will be noted on the panel. So here the speed will be there once we'll run the engine. Now another thing is the generator, DC generator come the motor. As I told you, so we will going to run the engine on the two modes. One is the generator mode, so when the fuel is consumed, combustion is taken place, and then at the second end, so motoring mode. So at the second end, motoring mode, no fuel is consumed, only this motor will going to run this engine. Motor is going to run this. So this is what the generator cum motor, so it works on the reverse mode. So why we are doing this? Because frictional power is the same when you run it on engine mode, generator mode, and when you run it on a motor mode, because the piston cylinder arrangement is moving. So that is the main thing. Now on the other side, what we are having, so this is a air box. So air box through which the air is passed and the measurement of the air is taken place. So basically, so the air is entered and the difference in delta H, so that is calculated already. The only through the electrical connection, so the reading will be there on the panel. So through the air box, through the electrical connections, so what we are getting a amount of the air consumed on this panel. So you will see the amount of the air consumed. Right now this is a dummy reading. So this is the meter cube per hour, the amount of the air consumed it will be there. So there is no need to calculate delta H, no need to measurement, calculate the coefficient of discharge, area, everything is fixed, and we are getting only reading as a digital reading, and that is the final reading we are getting on this panel. Now what else is there in this rig? So exhaust gas calorimeter. So this is exhaust gas calorimeter. So this device, so this is basically to remove the heat from the exhaust gas. So various water circuits are there. So this is exit water going on. So this is the inlet water is also there. You see this pipe is there, inlet water, and through this, so the measurements are there. So you will see the measurements on the rotameter. So this is one reading, the water passing to the exhaust gas calorimeter, then the another reading, the water passing to the engine. So this will be one circuit. So this will be there, and first passing to the calorimeter, it enters in the calorimeter. So this is basically a shell and tube heat exchanger, and then on the other hand, the exhaust gas, after gaining a heat from the exhaust gas, it will be moved to the dump. Then the another thing that will be there is the various temperature reading. So these are the thermocouples. So various thermocouples are there. This is one thermocouple. I will just remove it, try to show. No, it's not open. So this thermocouple is there. So in the thermocouple, so like this, so we are having many thermocouples attached. So the thermocouples will give you the direct temperature reading on this node. So we are having the total 6 thermocouples on the test rig. So you will get a reading 0, 1, 2, 3, 4, 5, 6. Like this you will get the various readings. Right now 6 is the ambient temperature. The ambient temperature 29 degree by default it is shown on the digital panel. So this is something about the engine exhaust gas calorimeter. Now this is a panel. So on the panel what we are having? So we are having a main knob, motor and a generator. Right now it is a generator. So when we'll move it to like this, it will be running on a motor mode. So we'll change it, and right now it is running on a generator mode. So we are having the two buttons here, increase and decrease. So once we start the engine on a no load condition, to have a fixed RPM, rated RPM on this, so we'll increase and decrease the speed on this knob. Using these knobs, so we're going to increase and decrease the speed, and then with the help of the, so you could vary the current, we will vary the current, and then so that the load will be there. So with the help of this we could vary the current, and this is all about the panel. Now this panel is for a engine, and once you run it on a motor mode, we'll see all of the connections are on a switched mode, and then this is the panel on the right hand side. This will be for a motor mode. Once we use it for a motor mode, you could switch on and off through this, and you will get a voltage, how much voltage we will apply, then how much current, and we will slowly increase this, so till the RPM is same to the previous one. When you run it on the engine, so as we see on the blackboard 2800, the same RPM. When you are using the motor mode, when it will come the same RPM, then you will take the voltage and the current, and that is the fixed. So this is the panel on which you will get all of the readings. So we are running first on a no load condition, and this is the resistive load bank. So this is what the resistance load bank on which the various loads will be applied. First will be the zero load, then you could apply the 500, like this will move it to the down. Now it is the 500, so another 500, now it is the 1000, you want the another, so this is the 2000. Like this we will increase or decrease the load. So these all are the things so related to the resistance load. So resistance load is what? Basically the load applied on the engine. So load applied, you will see this is input, through this the current is passed, so then through this arrangement the load will be applied to the engine. So this is all about the various things. So okay, the last thing is still left, that is the amount of the fuel mileage. So this is the amount of the fuel mileage. So as we are doing it manually, I told you we don't have the digital measurement of the fuel. So here, so the amount of the fuel consumed. So we are having this bulb. So the capacity of the bulb is 40 ml. So we'll note down the time with the help of the stopwatch. So the amount of the fuel consumed through this 40 ml. So 40 ml divided by the time, so is the basically the specific fuel consumption. So when we have to note it down, we'll close the supply from this top tank. So this is a top tank in which fuel is stored. So we'll close the supply, and now it will be slowly moving down, and finally it will be going to pass this line. 40 ml is finished. Now note the time, and that is the first reading. So we'll again do it back so that we keep on the So this is all about the testing various things. Now let's start the equipment. So some of the common instructions to start this, that before the start of this engine, so please check the fuel. There is a fuel in this, so we have already filled the fuel, so fuel should be there. Check the various electrical connections, there should not be any loose connections and all. Check the thing that the water to the exhaust gas calorimeter is flowing. So the water to the exhaust gas calorimeter through these knobs and to the engine. Before the start, that should be checked. It should be in a open mode, and then only you should start, so that the water is started circulating. So that circuit should be completed. Now once that is there, checking all the things, now you could start the engine. Now we'll start the engine and we'll take down 1 or 2 readings and we'll try to do the experiment. So you see that, okay, you see now we have started a engine. So the RPM is near to 2800, although this fluctuation is going on. So RPM is there. So this right now this condition is a no load condition. So this is what the no load condition. You see this knob. So this is on a generator mode. So generator mode is there. So this is the first set of the reading. So when we'll do it on a motor mode, so this knob should be on the reverse hand side. So these are the temperature readings. Right now ambient temperature, you could see various temperature readings. So first temperature maybe this is on the exhaust gas. So then the various other temperatures might not be working properly, but all of the temperatures are there on the test switch. So temperature readings are there on the panel. Then you will see the amount of the air consumed, 5 meter cube per hour, that will be there. Speed is there, no load is there. the engine is now running. You see 6 RPM, engine is running, and these all conditions are there. Now what we will do, this is the first set of the reading. Now we will apply the load to the engine. So we will apply the load. Now you see the 500 load is applied to the engine. So you see the fluctuation in the current and the voltage because of the application in the load. So we'll try to see this. The RPM is so little bit, yeah, with the application of this 500 load. So there is a little drop in the RPM, but we try to increase the speed and the load so that the RPM will again the constant. That will be there. Now how to measure the fuel? So we'll take down all of the readings and we'll try to measure the fuel. So what we will do, so you see this, we'll switch off this. Now the amount of the fuel, it will be passing through the valve. It will be there. It is still going on. Now you see this, so it is moving down, moving down. It is moving down. So once it reach at this level, so that is the time to note the reading for a fuel measurement. So once it reach at this level, that will be the time to note the reading for this. So we'll move it down, we'll see this. It is still not come. Yeah, still. Yeah, now it has come. So once it is there, now we'll start the reading on a time watch, stopwatch. Okay, so we start the reading with the stopwatch. Now the fuel is consuming. So we'll see amount of the fuel consumed in a fixed time. Once this fuel consumed, it will be reached at this level. So you stop the stopwatch and then that time will be noted. So this is the first set of the reading for a fuel consumption, and you will note down the first set of the reading on all of this. RPM, current, this amount of the air consumed, various temperature readings. So all of the things are there. Load applied, it will be the 500. This is the first set of the reading is complete. So similarly, how will you do the second set of the reading? You increase the load to the another 500. Now the load is the 1000 watt. So this will be RPM. We need to fix the RPM again into the 2900. Amount of the air consumed, I, V, various temperatures, then amount of the fuel consumed again, that will also be noted. So this will be noted down. So like this way, the second set of the reading is complete. Similarly, third set of the reading. Now the load applied is 1500. Now you will see current, voltage, various temperature reading, amount of the air consumed, RPM, then again the amount of the fuel consumed. So plus these readings are also there. You should also note down these readings. So the amount of the liter. For all of the previous readings also you could note down. So right now it is the 2.2 liter per minute. So similarly for the calorimeter it is 2.3 liter per minute. So 2.3 liter per minute for a calorimeter, 2.3 liter for a engine. So this should be also noted. So one set of reading, second set of reading, third set of reading, fourth set of the reading, all of the readings you have to note down. So this will be completed one set of the reading. Now we have seen that, so we take a first set of the reading. Now for a motoring test, you see the amount of the supply that to the engine it is cut off. So here also there is another cut off. You see this is also switched off, so that is also cut off, and then we are seeing that the spark plug, so this spark plug is also removed, so that we are taking no risk. Now this engine is not in a working mode, it will only move with the help of the motor. It means that there will be no combustion, so only this engine will move with the help of the motor. So from this panel what we will do, so we have switched from the generator mode to the motor mode. So now we have switched it from the generator mode to the motor, and then there will be no load through the resistance. All of the loads are on the 0 position, off position, so there will be a fuel amount of the air consumed, that should also be not to be noted. All of the readings not to be noted. Now we will only see voltage and the current applied to the motor. Now we'll start this. This is in a on position. Now we'll start, try to move this, apply the voltage and the current to this. So we'll see this. You see this, we are increasing this load. Now you see this motor is started moving. Now you see the motor has moved. Now we will slowly increase to 3 and I till the RPM is 2800. Because the first reading we have taken, it has a 2800. So it is slowly increasing this voltage and the current till the RPM will be 2800. That is the rated speed. We are doing at a rated speed. Now see, the RPM is 2800. How much is the voltage? 133 volt. How much is the current? 10 ampere, 10.7 or 10.6 ampere. So we will take VNI, we will take the RPM reading, and then the experiment will be going to complete. So the experiment will be completed with the same set of the reading. So right now it is running it on a motor mode. So now what we will do, we will again switch off the motor and we will do the second set of the reading for a reading. We will switch it off. Now the motoring is switched off. We'll move back. So now this is not in a working position. So now we'll move it back for the second set of the reading. Now for the second set of the reading in a generator mode. So like this way we will repeat as we have did the first set of the reading. We will repeat it for the second set of the reading. So first set of the reading, second set of the reading at the another variable compression engine. Now it is in a generator mode before the second set of the reading. So what we will do, we will vary this variable compression at any fixed thing. So fix. Now this is changed. So this will be changed. The change will be noted from this scale. What is the change in the variable compression? So to start the second set of the reading, we will again repeat the experiment. Second set of the reading, we'll do a generator mode, and then again we will do a motor mode. Then for third set of the reading, again variable compression, we'll do a generator mode, motor mode. Likewise, so fourth set of the reading on the different compression ratio, we'll do it on a generator mode as well as on the motor mode. So once we are ready with the all of these readings, now it is time to draw the various graphs, time to do the various calculations. You could calculate the brake power, you could calculate the frictional power, you could calculate the specific fuel consumption, you could calculate the many other things, and then you should draw the graph between the brake power versus the thermal efficiency, brake power versus the any other parameter, or you could draw the graphs between the n number of the parameter with the n number of the parameters that is available. So once you draw the graph, and your experiment will be completed. So at the end what I will say, so in this experiment what we have learned how to check the performance of a variable compression engine using the rated speed and using the variable load. Using the rated speed means fixed speed and variable load means the variable load that we have applied through the various means of the thing.